Alright, now that you know what a combination is, let's introduce some notation. Just like we had with permutations, we're going to define C of n comma r to be the number of sets with r elements taken from a set with n elements. And what we did in the last video was we figured out that C of 4 comma 2 was equal to 6 because we had the 4 friends and we were picking 2 of them to give tickets to. That's where we got 4 and 2. And then we just listed out the 6 combinations. In fact, we listed out 12 things, then we had to cross some of them off because they were duplicates. So in the end, we ended up with C of 4 comma 2 is equal to 6. Let's figure out a formula in general for the number of combinations for any n and any r. Alright, so let's suppose what we want to do actually is count the number of ordered lists of r elements taken from a set with n elements. We could do that process in 2 steps. We could first just pick the r elements from the n elements, right? So we could just pick a set of r elements from our big set of n elements, and then we could arrange those r elements, right? So we can take this one process and break it up into a 2-stage process. And actually, we know how to do these 2 things. We know how to count these already. This is exactly a permutation. This is also a permutation where I have r objects and I'm just arranging those r objects. And then if you notice, what we have right in the middle here is exactly this definition of C and R. So there's a formula that we have, and now we know how to compute the 2 permutations so we can compute the combination. So what I'm going to do is we're just going to divide both sides by this permutation over here, and we'll get that the number of combinations is the number of permutations divided by another permutation. And now let's plug in some formulas. So we know that Pnr is n factorial over n minus r factorial. We also know that PRR is actually just r factorial. And so we get our formula for the number of combinations. Here it's just n factorial divided by n minus r factorial times r factorial. And let's check that this formula works with what we figured out in the last video. So if we were going to figure out C42, that would just be 4 factorial over 2 factorial times 2 factorial. And now there's a number of ways to do this, but these numbers are small, so 4 factorial is 4 times 3 times 2 times 1, which is 24. 2 factorial is 2, and 2 factorial is another 2, so combined that's 4. So we get 24 over 4, which is 6, which is exactly what we got in the previous example.